David Kurd, warm welcome from the faculty and all the guests here at Humboldt University. I'm the Dean of the School of Business and Economics, and I cannot say it with truth. We are proud and we are honored that you are our guest today, and we'll give a talk about your main research topic, migration and wages and minimum wages, which is very important in my view, because it's still in the debate. We talk a lot in politics, and so it's a topic that I look very much forward, and I think all the guests here also. We are honored because you are a Nobel Laureate from 2021 that is in the Corona pandemic, and you got this Nobel Prize together with Joshua Angrist and Guido Imbens, that we also know very well, who have also visited Humboldt University and gave guest lectures and seminars. And you have made important steps or research contribution, as far as I understood, on the relation between, or on the topic correlation and causality, which is also a topic that we try to teach our students straight from the beginning, that correlation is not causality. And we look very much forward to your talk. Yes, we are honored and we hope for a discussion. David told me in the before the talk that he was here 1993, just when the faculty was reconstituted and refounded after the wall came down. That is a long time ago. Many things have happened since then, but I learned that you know some of the colleagues back then, and we will continue this discussion after your talk.
Yes, so thank you very much. And again, many thanks to Humboldt University for the unwavering support we have had at ROCKWOOL Foundation Berlin over the years. Now, I'm very pleased to welcome you all today to RFBerlin's first public lecture. We will have these events every year. And what we see here today is organized by the ROCKWOOL Foundation Berlin Institute for the Economy and the Future of Work, together with Humboldt University. We welcome David Kurd. David is Canadian-American and professor at the University of California, Berkeley. In 2021, as you all know, he was awarded the Nobel Memorial Prize in Economic Science. His research has profoundly shaped our understanding of labor markets, and in particular in areas such as the minimum wage and immigration, which are the two topics he will be talking about today. Going back to the years of David's career, he has played a key role in transforming how economists established causal relationships. Today, we call that often the credibility revolution. Much of his work has utilized natural experiments to provide compelling evidence of the causal effect of labor market changes on all sorts of outcomes. One of his most influential studies that was conducted in the early 1990s with the late Alan Kruger examined the impact of raising the minimum wage on employment in fast food restaurants in New Jersey and Pennsylvania. Their findings, which basically showed that raising the minimum wage did not lead to job losses, challenged long-standing economic beliefs and sparked a rethinking of minimum wage policies, which kind of lasts until today. I myself recall attending the 1995 American Economic Association conference when David was rewarded with the prestigious John Bates Clark Medal. It was, as a young scholar, fascinating for me to see how aggressively the established economic community related and reacted to his work on the minimum wage. I've never seen something like that before. Today, nearly 30 years later, David and Alan's early findings and David's work in many years after his first work on the minimum wage, have been validated by many empirical studies across different countries, including Germany, and have deepened substantially our understanding of labor markets. His work on migration has also been groundbreaking. David explored in a very early paper how immigrant workers affect native workers' wages and employment opportunities. And in his 1990 study on the Mariel Boatlift, which is a seminal piece in this literature, he applied something which was called the difference in difference methodology. A difference in difference methodology, a tool that became central to the credibility revolution and to the identification of causal effects using microdata. This approach has transformed how economists establish causality in empirical research, but that work on migration didn't stop there. In many papers afterwards, for instance, his work with Joe Altonji and other co-authors, David, had a big impact on our understanding of the impact of immigration on labor markets and wrote many important papers. Now, I myself pursued a PhD on immigration, which many people told me at the time would be a complete career killer at the European University Institute. And I was personally influenced by David's work during a time when immigration was not really a topic economists would work on. There was a handful of economists, I would think, who worked on immigration. I was fortunate to have David as a member of my thesis committee, and his guidance has shaped my research in many ways in the many years to come, and I'm very grateful for that. Now, throughout his career, David has made substantial contributions to many other areas of labor economics, not just migration and the minimum wage, to areas like education, returns to schooling, inequality, and wage structures. His methodological innovations have had lasting impact on the way we conduct empirical research today. A latest example has been his recovery of what is called today the AKM effect, which for many years was basically buried away in the literature. The profound influence of his work on both academic economics and public policy cannot be overstated. I am extremely honored and excited that David has agreed to give the first RFBerlin public lecture, and I am sure that his insights will leave all of us with a deeper understanding of the key economic issues that shape our world today. Please join me in welcoming David Card.
Thank you very much for that kind introduction, two kind introductions. Very nice to be back in Humboldt. I was telling a couple of people over the last 2 days that I was here. I mistakenly thought I was here a little earlier than I was. I was here in 1993 for a very early conference that was held here, and to tell you the truth, I haven't really been back except for an overnight stay, and so it's really nice to walk around and see how things have changed. I was glad to see that some of the sewer pipes are still above ground, because that was definitely a thing I remember from 1993. Anyway, so thank you all for coming, and I really look forward over the coming years to the chance to come back to Berlin and the ROCKWOOL Foundation and Humboldt and see how things develop from here. So today I'm going to give a talk, and this is sort of a public lecture, so it's not technical, about cause and effect in the labor market and how that relates to these two topics of immigration and minimum wages. And just to sort of set the stage, it's kind of useful to remember that the whole field of economics, or really what used to be called political economy, was really founded by people who thought they should be telling other people what to do. So that persists today in economics. And so people were arguing about public policies. So Adam Smith wrote his book, The Wealth of Nations, largely to argue for freer trade, to argue against mercantilism. Now, if you listen to Donald Trump, you realize that argument is still going on today. David Ricardo wrote his famous pamphlets and developed the theory of comparative advantage, basically arguing for free trade between Britain and Portugal in particular. Francis Walker, who's not as well known a name as these two, but was the founder of the American Economic Association, is probably best known for his very strong, essentially racist views about arguing against immigration. So these are examples. If you read those papers or books and a lot of the earlier work in economics, you realize that people were informed about some of the facts about the world around them. But of course, they didn't have quantified survey data. They didn't have national accounts. They didn't have much of the data that we rely on. So in fact, most of what they were arguing was based on theoretical arguments about how the labor market or how the economy worked. And I would say that in my years in the economics field, which is getting on to almost 50, there's been a shift toward the idea that the recommendations and things that we use to try and help make policy should be more evidence-based. Now, evidence-based policy requires evidence. And an example would be, if you want to know how does the arrival of migrants affect native labor market opportunities, you need to have some way of saying, well, how did it affect things in the past? Or how did something like an arrival of immigrants affect the labor market? So today what I'm going to do is I'm going to try and start from the idea of what is scientific evidence. I'm then going to go on and talk very briefly about the idea of randomized experiments. And this is helpful for introducing a concept that people are somewhat aware of, but people outside of economics may not be quite as aware of. And to tell you the truth, the word counterfactual wasn't even used in economics until about 10, 12 years ago. So actually one of the major contributions of my friends Josh Angrist and Hito Mbens was to help introduce this idea, this language into economics. I'll talk about social experiments and then natural experiments, and then I'll talk about applications of the ideas there to these two topics. And then at the end, I'm going to come back and talk about something that is important for economists to acknowledge, which is it really the case that policy choices are affected by evidence? What do we really know about that, and what should we think about that? So I want to start with the idea of scientific evidence. And in North America, certainly I was taught in high school this idea of proposing an hypothesis and trying to test it. And the way that we teach that to younger students, I think, is best illustrated by something like Boyle's air bell experiment, which you probably have heard of. Mr. Boyle is the guy who discovered Boyle's law, which is the law about temperature and volume of gas. But he was well known in Europe for going around and showing that oxygen or something in the air was necessary for life. And the way he did that was he had a big glass jar with a dove in it, and he invented the vacuum pump. And he had a way of sucking the air out, and then the dove would die. And people enjoyed that. That's just a picture of that, well-known picture. And you can think about that as an experiment, but it's a case where it seems like just one observation is decisive. So I call that a single decisive measurement. And a lot of times, I think we leave with our high school students the impression that a lot of debates can be settled in that way. And the most famous example from the 20th century probably is Einstein's theory of relativity, which gave a prediction about the bending of light coming from the site of Mercury coming around the sun. And he made this prediction. A bunch of people, famous physicists, set up the device to try and test it, and it looked pretty clearly like he was correct when those first results came out, just before World War I. And so he became famous almost overnight from that basically single decisive measurement. Unfortunately, in many areas, including ours, economics, or mine, economics, it's not really the case that there's a single decisive measurement that's going to really convince hardly anybody of hardly anything. And the reason why is because in economics, unlike most fields of science, the relationships that we're trying to test or propose are probably best thought of as statistical regularities rather than like iron laws. So what have people tried to do to deal with that? Well, one way that this came up in the history of science was thinking about evidence for and against vaccinations. The first this is a picture of a vaccination going on. The reason why it's called a vaccination is because they used women who looked after cows were noticed to have cowpox, which is a mild form of a disease that's closely related to smallpox. And it was noticed that the women who looked after cows rarely got smallpox, and so people got the idea of taking I don't know actually who thought of this, but got the idea of taking the infection from the wound of a cowpox and inoculating other people, and it turned out that that worked. So there was a famous example around the end of the 18th century where they basically vaccinated a whole bunch of people with that, and it seemed to work. In the late 19th and early 20th century, these ideas started to spread to agricultural economics more generally, or agriculture more generally, and there was a lot of interest in hybrid seed, you're following from Mendel's experiments and so on. And a famous contribution was made, or a series of famous contributions were made by the statistician R.A. Fisher, who was called in to try and straighten out the data from a famous agricultural research farm in England. And researchers at that farm had been planting fields and with alternative crops and measuring the results from year to year for quite a long time when Fisher was brought in. And at that point, it was they really thought that they weren't really learning anything. And Fisher realized the problem was that they weren't doing a very good job of trying to keep track of where one seed was planted and another seed was planted, and in particular to make sure that they weren't privileging the location for one seed versus another, and that the conditions were kind of under control. And he came up with the idea of assigning plots in groups. This is actually a picture of the field. This is his famous 5x5 experimental design. So in this 5x5 design, there's 3 different crops planted in a sort of quasi-random way across these 25 squares. Now this is, if you know anything about statistical design, this is called a Latin square. Okay, so what's going on with these ideas eventually became organized, and it's kind of remarkable how late it was in the history of science. It was probably around the 1920s when these ideas got really organized into the idea of what we now call a randomized controlled trial, or RCT. And the simplest possible randomized controlled trial is illustrated here. We divide some population of interest into 2 groups, control group and a treatment group, and we do it randomly. Okay, and I'm going to come back and talk about why we do that randomly, but that's why randomized is the first word. And ideally, the subjects of the treatment and control group don't know which group they're in, and that's the origin of the term placebo. So you basically give the people in the control group get a placebo, so they think they could be treated, and the people in the treatment group get something that could be the placebo. No one really knows what their true status is. And even further, in an ideal medical experiment, for instance, the researchers studying the subjects don't know who's been treated and who's not. And that's a so-called double-blind experiment, where both the subjects themselves and the people doing the measurement of the subjects don't know who's who. And the idea after this is all done is you're going to compare the outcomes of the treatment group and the control group. That's going to be how you evaluate the proposed treatment. So what's going on? Why does this work? Well, and this gives me a chance to bring up Star Trek, which I never want to miss. Okay, so if you randomly split the population into 2 groups, then you would think, because of that random split, you would think that those 2 groups would evolve similarly. Okay, there's no reason why their outcomes are different. So if you just took a random sample of the population and watched them over the next 5 years, they should have the same income, they should have the same labor market outcomes, they should have the same number of children, and so on. So if you took a random group and you gave one a set of treatments and you gave the other a controlled placebo, you might then be able to attribute any difference between the outcomes of these 2 groups into giving them the treatment, because that's ideally, in an ideal world, that's the only thing that's been manipulated apart from this random split. So that's the idea. And the way that you think about it is that the control groups provide a counterfactual for what would have happened to the treatment group if they hadn't been treated. And the way I explain this to people the first time when they're taking a statistics class is it's the mirror universe in Star Trek. So if you remember, no, I'm sure none of you remember because you're too young, but in Star Trek, a recurring theme was that you would somehow go too fast or somehow mess up space-time. And as a result of that, there would be a parallel universe evolved. And this is bad Spock and bad Kirk. You can tell they're bad because they have facial hair. And they are going to be fighting with good Spock and good Kirk later on in the episode. And a lot of policy debates emerge because there's an argument when we see an outcome that we don't really know what the counterfactual would be. And there's a really good example of that right now. In the United States, people are fighting like crazy over what caused inflation after 2021. Was it too much government spending? Was it supply chain problems? Or was it some third intervention? And the problem is that there's no counterfactual because there's one US economy. Okay, we didn't randomly split the country in half and give half no supply chain interruptions and no macro interventions. And so in a lot of areas, and especially, I apologize to my colleagues in macro, but a lot of debates in macro really keep going and never really get to any conclusion because you can't really say what the counterfactual is. Now, these ideas of RCTs became widely used and got to be more than just a small number of patients administered one version of a drug versus another version of a drug. An example from early 1950s, just before I was born, Salk invented a potentially useful vaccine for polio. And polio was a major threat. It's a disease that affects young people. It's extremely contagious. And many people get it and nothing happens, but a small fraction of people who get polio are permanently disabled for the rest of their lives. And some even lose the ability to breathe, and so spend the rest of their lives in these iron lung machines. And when I was a kid, there was still a significant population of young Canadians who had been lost lung function and were living in hospitals in these pretty difficult situations. So in this famous polio trial, one of the big charity organizations, which had been lobbying for a long time to raise money to fight polio, the March of Dimes Foundation, managed to get 1.8 million children enrolled in an experiment across Canada and the United States. Now, 1.8 million people in an experiment is an enormous experiment. It was a major, major thing. Why did they need such a big sample? Well, one problem is polio is very contagious, but it hits an area and then moves on. So if you take a country like the United States, although one county or one area might have a fairly high rate of polio one season, it was extremely difficult to predict what season that would be. And if you look in the nation as a whole, the incidence rate was only 50 out of 100,000. So you're going to need a really large sample to find a significant number of kids who got polio, and also to find a significant number that could have gotten polio if they hadn't had the vaccine. So they did this enrollment, and within a year and a half, it was very clear that this vaccine worked. And so it kind of revolutionized treatment of polio, although, as you've been following the news, there's been a resurgence in the Middle East. So it's not a disease that's fully gone even today. Now, this idea then has taken hold in medicine, and these days, the US agencies require new pharma drugs to be tested by an RCT, rigorously controlled, randomized controlled trial, very expensive procedure. Somewhat controversial because some people who are advocating for faster innovation believe this kind of holds back progress. On the other hand, there's a few historical incidences where, because the FDA didn't approve drugs that other countries did approve, it ultimately prevented a lot of disasters from happening. So it still persists. In the 1960s, the enthusiasm for these kind of ideas started to spill over into innovations in social programs. This is the era of Great Society programs. And in 1966, a young graduate student at MIT named Heather Ross got the idea of trying to test a proposed innovation to the tax system. It was actually proposed by Milton Friedman, a very conservative economist. But the idea was actually supported by liberal economists as well, including James Tobin, who was in many other arenas, was kind of the foil of Friedman. And so Heather Ross wrote a letter to the Health and Human Services Agency in Washington. I once asked Bob Soler was her advisor. I once asked Bob about this, and he said, well, she just wrote it. Anyway, she wrote this letter, and she said, I propose that we do an experiment to evaluate the negative income tax that these guys are proposing. And for reasons that are kind of unclear, it took off. And eventually, 4 different negative income tax experiments, as well as a healthcare experiment, were all done at the end of the 1960s and into the early 70s that are still talked about today. Actually, there's still papers being written about them because there's some difficulties in how they were run and somewhat difficult to implement or understand. By the late 1970s, the enthusiasm for these large-scale social experiments was sort of dissipating. At the same time, it had turned out that there were some serious problems in the design of the social experiments. The famous negative income tax experiments had a problem of following people. So they enrolled a bunch of people in the treatment group and the control group, but unfortunately people moved and they didn't have a very good way to keep track of who was who, and they lost more people in the control group than they lost in the treatment group, and so it became kind of a mess. The next generation of social experiments were more modest in scope. Those started in the early 1980s when I first came into the field of economics, mostly in manpower training topics, or what used to be called manpower training. And these experiments eventually set the stage for the kind of experiments that are widely used nowadays in development economics. This picture of Esther Duflo and Abhi Banerjee, who won the Nobel Prize a few years ago for their path-breaking work on trying to get RCTs to evaluate policies in developing economies. Okay. Now, RCTs are great. You can credibly estimate counterfactuals because of this parallel universe property. The problem is that there's a lot of limitations of RCTs. It's sometimes difficult to convince policymakers about RCTs because you're going to create inequality. You're going to randomly create winners and losers if the treatment turns out to be good. And some people really don't like that. More substantively, it's very difficult in a lot of circumstances to know if the results in the RCT will scale up. And that's a criticism that's often raised of these small experiments in development economics. You can get something going on in one village if you give some people one thing and other people another thing, but it's hard to know if you tried to implement that on a national scale, would you be able to make it work the same way? And of course, many policies can't be randomized. But if you think about it, there's a lot of situations in real life where there is a difference between groups. There's one group of people or one group of firms that are exposed to some treatment, and there's other groups that aren't. And so it's kind of natural to ask yourself, what can we learn from those observational comparisons? And those are the kind of comparisons that are at the root of what we used to call correlation designs, okay? And remember, we heard already, correlation does not equal causality. But here's 2 examples. You get a rise in the minimum wage in one state, so New Jersey versus Pennsylvania. I'm going to talk about a recent study that I found kind of fascinating. It looks at was there reputational damage to German car makers outside of Volkswagen as a result of the Volkswagen diesel scandal. So what happened to Daimler and BMW as a result of this scandal about what VW was doing? And you could say, well, there's a treatment group, those 2 German car companies. There's a control group, American car companies and Japanese car companies. So situations where one group is exposed to treatment and another is not are sometimes called natural experiments. And in principle, there might be something to learn from that. But the question that underlies the interpretation of those comparisons is just the question you want to think about, which is it really true that evil Spock and evil Kirk are the right control group for good Spock and good Kirk? All right, is that exactly the right counterfactual? So oftentimes, 2 groups, one that was exposed to treatment and one that wasn't, are very different for lots of other reasons. And you can't really know whether those, how to interpret the difference, because some of it might be these other reasons. And the insight of a difference in differences design is that if you think that the difference between the treatment group and the control group is some kind of permanent characteristic of those two groups that in the absence of an intervention would stay at the same level. So if you say, all right, incomes in California are 30% higher than incomes in New Mexico. And if we don't do anything, that 30% differential is going to persist. If we then introduce a massive investment in New Mexico, we could then say, well, in the absence of that investment, New Mexico would stay at 30% below California, but if we make a big investment, they might gain relative to California. That's the whole idea. So what you're going to do is you're going to take the difference between a control group and a treatment group before the treatment happened, and you're going to take the difference after, and you're going to subtract them. You're going to compare the relative size of the deviation. That's the difference of differences. So for instance, in this diesel scandal comparison, we're going to think about comparing sales growth for different kinds of cars in the US. Throw away Volkswagen, they're screwed. But let's take a look at BMW and Daimler compared to General Motors, Ford, Toyota, Nissan. So the first example I want to talk about is a paper I wrote in the early 1990s. And this came out of a conversation with one of the undergrads I was working with at Princeton. At that time, undergrads at Princeton had to write a senior thesis. And one of the undergrads, Konstantin Alexandrakis, his name was from Miami. And so this is 1987 or 88. He came into my office and said, I'm interested in trying to study the effect of the Mariel Boatlift. And of course, being from Canada and being an academic, I didn't really know what the Mariel Boatlift was, although I had watched Scarface. So if you watch the movie Scarface, you might remember the opening scene. This is, of course, one of Christian's favorite movies. You might remember the opening scene where Al Pacino, as Scarface, is getting off the boat and being processed at US immigration. So what happened is, in March 1980, there was a demonstration in Havana. A large number of people were complaining about repression in Cuba, and Fidel Castro got the idea that he could kind of quell this it was kind of a public relations mess, by saying, okay, anybody wants to leave, we don't restrain people in Cuba. Go ahead and leave. Just go down to the port of Mariel, get somebody to pick you up. Now, he apparently wasn't thinking too far ahead, or maybe he was, it's hard to know. But the port of Mariel is just outside Havana. It's only a couple hundred miles to Miami. And there was a large number of Cubans in Miami. So what happened was, the Cubans in Miami set up a flotilla of boats and brought back 125,000 people in about 2 months. Now, from the point of view of the Miami labor market, this was kind of controversial. You can imagine that was about a 7% increase in the population in the course of a matter of a couple of months, which is even by modern standards where people are talking about mass migration flows and so on. 7% is really big, okay? And so what Konstantin pointed out to me was that this had been controversial at the time. No one seemed to know whether this was good or bad for the Miami labor market. Everyone, the kind of anti-immigration people, even back then there was anti-immigration people, were sort of saying that this was a terrible thing. Other people said this was great. And he tried to do a little bit of work on it, but he was just a senior at Princeton. So eventually I wrote a kind of a pretty short, simple paper. I got the idea from this difference of differences thing of looking at 4 cities as a group that had trended kind of similar to Miami. No single city really was exactly the same as Miami, but I found if I averaged Tampa, Atlanta, Houston, and Los Angeles, I could get a set of cities which in the previous years had more or less behaved like Miami, and I could then try and do a difference of differences. And here's kind of what the data looks like. The Mariel Boatlift is here. This is the years. So this Mariel Boatlift is here in 1980. And this is data from the current population survey that looks at the average weekly wage of low-skilled native workers in Miami between 1973 and 1991. These are inflation adjusted. And I don't think people in the United States kind of know this. Maybe people outside of the United States aren't as aware. But the 1980s was a pretty tough time in the US labor market, and real wages were falling quite substantially. It was a period of high inflation and pretty bad unemployment. So real wages fell 15 or 20% between 1979 and 1985 in Miami for these low-skilled native workers. And if you don't have a control group, you can kind of see what the problem is. You could say, well, oh my God, the Mariel Boatlift was a disaster. It caused real wages to fall 25%. And this is the kind of thing, this is the kind of argument that macroeconomists are making all the time. So you can kind of see what the possible problem is with that. Now, putting the control group on really helps a lot, you can see. Because I'm calling it synthetic Miami. This is actually not exactly what I did. This is results from Giovanni Perri, and his co-author's name is something Yazanov, I think Isaac maybe? Anyway, they did a better job than me of getting the data from beforehand. But you can see if you look at Miami versus this group of other comparison cities, they're trending pretty similarly. And if you just had the control group, or just had the treatment group, you might be tempted to make all kinds of accusations about the effect of immigration inflows. But if you have the comparison group, it puts a lot of discipline on that. It's not really so obvious that there's any effect of migration. Now, in economics, especially when it comes to these sort of small-scale studies like that, that study was kind of interesting, but it's more a proof of concept than an actual, solid piece of evidence that you want to say, for sure I understand what's going on. So what happened is, good for me, I guess, people got interested in trying to apply this idea in other settings. So there was a study of the effect of the repatriation of French nationals out of Algeria at the end of the Algerian War. There was another study of the very similar repatriation of Portuguese nationals back to Portugal at the end of the Angolan War. A couple of studies of involving movement out of Russia, one of Russian Jews to Israel after 1992, and one of the migration of ethnic Germans who were able to come back to Germany after 1991 or 1992 under the German laws. And so these studies, as well as some other ones, basically followed the same idea. Try and get a treatment group and a control group and see what happened. And for the most part, these show very similar results, very small effects on natives. The case of the German migration, there is a little bit more evidence of a wage effect. And other research designs trying to look at other ways of finding comparison groups for treatment and control with more and less immigration have reached a fairly similar conclusion that any effect of immigration on native wages is relatively modest and a lot of times close to zero. As an aside, since I know everyone is thinking about Volkswagen in Germany these days, here's the results of this analysis of VW, and it's going to be the same story. So what we got is, in September 2005, the EPA reveals that Volkswagen had installed this cheating mechanism so that the car performed differently when it was being tested than it did on the road, which was a great idea. You have to give them credit for that, but kind of sneaky. And this had large repercussions. And some people thought, well, this probably didn't just hurt Volkswagen. This hurt the reputation of the entire German car industry, because if they could fake that, it wasn't just Volkswagen who knew about this. There was a lot of supply chain suppliers who must have known, and whoever was doing the coding. There was a lot of people that must have been in on the deal. So if you can fake that, what else can you fake? So you might have thought, well, maybe the German cars, which had enjoyed a fairly good reputation, would hurt. And so this study by Bachmann et al. Looks at sales growth for German cars, excluding Volkswagen, and non-German cars in the United States market. And you can see the dotted line is the control group. The blue line is the treatment group. And if you just had the blue line, it'd be kind of hard to say, because sales growth is extremely volatile. It looks like wages in those cities. Bounces up and down. It might be trending in a certain direction. But having the control group allows you to see pretty clearly that around this time, a gap opens up. Pretty significant gap, which suggests that there was an effect, a spillover effect of this scandal. Second example I'm going to talk about briefly, the New Jersey minimum wage. So in early 1992, Christian alluded to this, New Jersey legislature decided to raise the state minimum wage from the same level as the rest of the country had pretty much, 425, to 505 an hour. This was the late stages of a recession, so it wasn't the greatest time for raising the minimum wage. Alan Kruger and I were both on the faculty at Princeton in the middle of the state of New Jersey. And we had been working on the idea of minimum wages, and we decided to try and construct a prospective difference of differences analysis. So we wanted to try and design a study that was as close as we could to an experiment, but we were going to use a natural experiment. So what we did was we went and surveyed a bunch of restaurants in New Jersey, that was our treatment group, and Pennsylvania, and we were kind of in a hurry, so we got everything done in February 1992, just before the minimum wage was increase was supposed to take place. And then we went back and surveyed the same stores in November 1992. Now, we made many mistakes in this paper. And one of them was that we probably should have waited until February because there's a lot of seasonality in the fast food industry. Okay, now, but we have a control group, and so hopefully that's going to be factored out. The other thing we couldn't really think of a way to deal with this, and subsequent work has dealt with this and much better, and I'll talk about follow-on work later, but we only had one observation prior to treatment, so we couldn't test that the treatment group and the control group had been going along together. That seemed to be important in the case of Miami and the case of the car sales, right? We want to make sure that they were going along together before the intervention. But we had an idea. We knew before we went into the field, because we lived in Princeton, and in Princeton, the restaurants were already paying more than $5 an hour. So we knew there were parts of New Jersey where they were going to raise the minimum wage, but it wasn't going to take effect. Now, we didn't know how big that group was, but we were kind of praying that it was going to be a reasonable size, because then we were going to have two control groups. We were going to have Pennsylvania, and we were going to have high-wage stores in New Jersey. So what happened? Well, here's the employment before and after, the number of workers, and you can see kind of almost the opposite of what you would have expected. We found that New Jersey was constant and Pennsylvania went down. So you might have thought, well, did they just label the points wrong? So I have to say, when we first saw these results, we weren't sure exactly what we did wrong. But if you take that at face value and say, well, the counterfactual for New Jersey was a downward trend in Pennsylvania, then it looks like raising the minimum wage, if anything, had a positive employment effect. Now, luckily for us, we had this other control group, these low-wage stores. It turned out there was a significant number of them. And these high-wage stores were already paying $5 or more. And if we plot them, they turned out to be following the same trend as Pennsylvania. So we felt like, okay, this isn't the greatest difference of differences study because we've only got one observation before, but with two control groups, we felt like we probably had enough to feel like we could make a conclusion that raising the minimum wage wasn't, at least it wasn't a job killer. So we basically found that if we compared the two designs, New Jersey and Pennsylvania versus high and low wage stores in New Jersey, we got the same answer. Later studies, there's been many, many later studies, many, are much better. And they're much better in several ways. One way is that they combine many state increases. Another way is that they have much more data beforehand, so you can be sure that the control group and the treatment group were moving along together before. They have longer-term follow-up, so you can see, well, maybe it took a while for the increase in the minimum wage to happen. And I would say most of those studies find very small effects of higher minimum wages. Some studies manage to find small negative effects, but most of them are pretty small or negative. And some studies look at prices and other things. We looked at store closures. Others have looked at that. Now, the last thing I want to talk about the idea that evidence-based policy is possible. And I want to use the case of immigration, because I think immigration is now extremely topical. If anybody watched the debate in the United States the other day, or followed the results of the recent elections in nearby Thuringia, I guess you call it, you know that this is an incredibly controversial issue around the world, migration. So despite research findings, immigration policies have probably tightened in most countries since 2000. So the evidence has sort of said, well, you know, the economic impacts of immigration you might be concerned about these negative impacts on low-wage natives. It's really hard to find evidence that that's an effect. So some years ago, Christian and I, together with Ian Preston, had the chance to submit a proposal to the European Social Survey. And we had the idea that we'd like to try and get at a fundamental question, which is, why are people so opposed to immigration? Is it because of these economic concerns, which is what the policy so far has largely addressed, the evidence, excuse me, has largely addressed, or is it because about concerns about something different than just the economic effects of migration? And we called these compositional effects. It's not entirely clear what the right way to label these effects are, but it's concerns about the effect that immigration has on the racial structure, the ethnicity, the religion, and the language of the country that you're in. So if you think of, when you think of people who are most opposed to immigration, and we were thinking about this, this paper was written quite a while ago, but we were thinking about this from the point of view of trying to understand the people that we knew who were most concerned about immigration. It seemed like these were the issues. And just by way of background, there was a recent poll in the United States. 1/3 of respondents said that they agree that immigrants are invading our country and replacing our cultural and ethnic background. Okay, so this is in the United States, this is called replacement theory. And it's extremely controversial, and 1/3 of people actually agree with that, straight up, like not trying to hide themselves or pretend that they're nicer people than they really are. So what we did in our study was we asked sets of questions on what you think about how immigrants affect economic outcomes, and we asked another set of questions on how you think they're affecting these compositional type questions. So we had questions like this. On the economic questions, we said, do you think it's true that immigrants lower wages? We also asked about how you think immigrants affect the budget constraint of the government and fill vacancies that might not be filled otherwise, and so on. And on the compositional concerns, we asked questions about things like, do you agree it's better if everyone shares the same language, if everyone shares the same religion? Do you think that that increases the harmony or causes conflict in the economy, country? And then what we did was we took averages of your views on economic questions and averages of your views on these compositional questions and related them to your views on the immigration question as a whole. And what we found was 80% of differences that people have in their views about whether we should have more or less immigrants come from these compositional questions. Only 1/5 of the concerns really come from those economic things that economists have been focusing on. So I think to tell you the truth, this work was done as I mentioned, some time ago, but I think that if anything, my view, I think Christian's view would probably be the same, is that these kind of non-traditional concerns are really more important than ever. And so what that means is that evidence on the economic impacts of migration matter a little bit and means that they're worth pursuing and trying to understand. But that might not address the real concerns that are underlying reactions to immigration. It's possible that that's true of reactions to lots of other questions like inequality. People might be concerned about inequality, but maybe not for quite the reasons that we think they're concerned about inequality. So on the minimum wage side, I think maybe the evidence has been a little bit more influential. So many US states have raised the minimum wage in the last 25 or 30 years. On the other hand, the federal minimum wage in the United States is stuck at a really low level. It hasn't been adjusted for a very long time. The UK introduced its first minimum wage in 1998. Germany introduced its first minimum wage in 2015. In both cases, there were a lot of people opposed to it and concerned about it, but the analysis that's been done suggested that the job loss concerns, at least, were pretty small, if anything, and so it hasn't really been the disaster that a lot of people thought it was going to be. Nevertheless, even though I did some work a long time ago on the minimum wages, I'm not entirely sure that all of these policy changes were 100% driven by evidence. It's possible that if the evidence had come in a different way, policymakers would have been a little less enthusiastic about raising minimum wages, but I hesitate to claim too much credit here. All right, so to summarize, this is my last slide. I think we can use experiments and natural experiments to understand difficult causal questions, and we've made a lot of progress in economics and social sciences generally on answering causal questions. And actually, the whole field of causal inference has become much more important. So in computer science, it's now a major part of what people are taught. And they're using same kinds of methods we introduced in economics in the last 30 years. Methods like difference of differences are widely used by academic researchers and policy analysts. RCTs are also widely used. Tech companies are doing RCTs every night on websites, whether you know it or not. And a lot of private businesses are also doing difference of differences and other non-experimental designs. Whether the evidence from RCTs and other non-experimental designs, it is affecting business choices, whether it's affecting government policy choices is a little less certain. And I think as economists, we have to be, speaking as an economist at least, I think we have to be a little bit modest about, we can get evidence. It's not entirely clear that that's the only reason. The things that we're researching aren't necessarily the only things that are mattering for policy. And so we maybe need to think a little bit more broadly, but I think there's been some progress, and I'll be glad to take some questions and hopefully have some reactions.